Okay, this is Kim Murphy. This is our CS 1400 class. We're going to talk a little bit more about objects, specifically the object references today. Do a little bit of a review and talk about passing variables and references to methods. Okay, so here is a pet class. Where are the instance variables? If you remember, the instance variables are private. So yes, we have two instance variables in this particular class. Okay, where is the constructor or overloaded constructor in this particular situation? Alright, yep, so that is correct. It's got two parameters, so it is an overloaded constructor, but this particular class does not have a constructor. So this would be our overloaded constructor. Can you find a setter? That's an easy one, because it has the name set. And then we have our toString method last. Okay, so all this does is it has a variable for the name and type of a pet. So the name would be like Fido, and Fido is of type dog, or Bubbles could be of type fish, or I don't know, what's a parrot's name, or a cat, Damien the cat. Anyway, so that's kind of what this does, and the constructor allows us to set the name and the type. We can change the name if we want to, and then we have a toString to see. It'll say Fido, or whatever name it is a, and then it will say what type it is, dog or something like that. So a pretty simple class, but I want to use this class to show you about some Java references. So when you declare an instance of the pet class, you use the keyword pet because it's the name of the class. So here I can declare a variable called shelter dog, pet shelter dog. If I'm going to instantiate that, what that means is I'm going to say use the new operator. Shelter dog equals new pet Fido, and Fido's a dog. All right, so declare means just give it the instance a name. Instantiate means bring it into existence using the new operator. Okay, so what is actually going on is when you declare the variable, you are allocating space in memory for the information to go. You're not actually putting the information in. That's why we have a little question mark here. When you instantiate the object, that means you're bringing it into existence. You're filling out the information. You could be using the default constructor, so you'd be filling out with empty information, but still it's whatever the default information is. A reference is the object's information. It was where it's stored. So you have a named object. So shelter dog is a reference to this location in memory. Okay, so here is another reference. I have dog, your dog equals shelter dog. So what I am actually doing here is I'm creating another reference to the same information in memory. So shelter dog points to Fido the dog, and your dog points to Fido the dog. This is a reference. Both of them reference the same place in memory because we're setting your dog equal to something without using the new operator. The new operator, remember, allocates that memory. Okay, so if I were to come in and say your dog, this is the second one, your dog dot set name Spike. So it's setting the name to Spike, right? Let me click so it does. There we go. So we know if we do a system.out.print for your dog, the name would be Spike the dog. What do you think would happen if we printed out shelter dog? So if you look at the place in memory where it's stored, shelter dog would also print out Spike the dog. We've lost Fido. And the reason why is because your dog and shelter dog reference the same location in memory. Okay, so now I have a different situation. I have pet your dog equals new pet Missy the cat, and pet my dog equals new pet Spike the dog. So I have a reference to this location in memory, and I have a reference to this location in memory. I have two references to places in memory. Okay, what would happen if I set my dog equal to your pet? Okay, here's my dog. It's setting equal to your pet. So if we look, I now have my dog referencing your pet in memory. So this position, nothing is now referencing this position in memory. So Java has what's called garbage collection. This is automatic, you don't have to do it, but Java is automatically going to delete that because it doesn't have a reference pointing to that location in memory. We've just referenced it to something else. Okay, once again, garbage collector gets rid of objects not being used. Automatic memory management for Java. Other languages don't have that. C++, you automatically have to deallocate your memory, but in Java, it's automatic. Okay, so now we're going to talk a little bit about objects and identifiers. So we have primitive data types. You have an int, double, a boolean, float, long. Objects are anything you instantiate. So pet, random generator, the scanner is an object. Anything you user-defined class, that would be an object. Strings would be an object. Okay, the difference between them is when you pass an object to a method, you pass a reference to that object. When you pass a primitive data type to a method, you create a copy. Okay, so let's show you an example how this works. Let's show you an example what happens when you pass a variable to a method. Here I have a public static void main, and I have an int num. So this int num equals 42. What it's actually doing is it's storing the number 42 in a position in memory. Okay, then it's going to go to our method. On our method, come on to the next one. Our method has a parameter of the information that's being sent. This parameter is a new variable, so it creates a position in memory as well. All right, so that will store that parameter. And this 42 gets copied into this parameter. So if I were to do a num++ like on the next line, and if I do a system.out.print statement for my variable, what's going to happen is it's going to update my location in memory with that 42 is going to become 43. And so if I look at this in the compiler, it's going to print out, oh, 43, because I have this num++. Well, as soon as it's done executing this method, the program focus jumps back to where the method was called, and it's going to finish off in main. Well, if you remember correctly, that num was pointing to this position in memory. So if I do a system.out.print statement in main, I am going to get that 42. So 43 up in the method because we incremented it, but it doesn't retain its value in main. It only sends a copy to the method. So that's what happens when you pass a primitive data type. So that is an int, a double, a boolean, a float, any of those primitive data types, it only passes a copy. Okay, now that differs a little bit when you pass an object. Let's show you what happens with the code when you pass an object. This is the same exact code, only I've changed the int to be point. Remember how we did a point class in class? There's our point. Point p equals new point. So this time, when I instantiate my object, this is going to take up more space in memory because there's more information to store. So it's going to take up a couple of places in memory for the 4 and the 2. Then it's going to go to the method call, and when it receives it, it's just going to send a reference of the same location in memory. So if I set the points, it's actually changing the points in memory. If I print out the points to the console from the method, it will show me those new updated points. But back at the method call, back in main, if I print out those same values again, I'm still pointing to that same location in memory, and so it should print out those changes. So when you pass an object to a method, it retains whatever changes you do from the method back to where it was called from. Okay, now going back, a string is a little bit different. If we remember back, we've got passes a coffee and passes a reference. That is true to an extent. So here I've got int, double boolean, float, float, but string is over on this side. But I want to show you how a string behaves when it's passed to a method, because it's kind of a different beast. Okay, so here I have main again, string str equals 1, O-N-E. So what that does is it gives me this location in memory for my string. Then I go to the function call, it comes up, it sends a reference. Indeed, it is passed by reference. The problem is there's no setters in the string class. You can't say set text to something else. No, you have to set it equal to something else. Remember what happens when you set something equal to something else is that's when it's going to allocate a space in memory for the second reference. So now we have string pointing to this place and it equals 2. However, back in main, it has not changed that reference from main. It's only changed the reference for this str. Even though they have the same name, they're two different references. And at this equal sign is what changed our reference last time. So even though a string does indeed pass a reference, since you can't change a string using a setter, it behaves like a primitive data type. So yeah, string's kind of weird. Well, that is it. I hope you've understood a little bit more with passing objects and passing references. We are going to have a little assignment in class that will really ingrain this into your brain on what is going on. And we'll see you there.